I would like to explain the some functions in the polynomial ADT. So it is a little bit difficult to write this theory. So for that reason, I write it on the paper and scan this one and put it in here, right? So we know that the polynomial is the sum of the terms, which is the terms are in the form of a x to the power of e, where a is a coefficient, x is a variable, and e is the exponents. Here I am going to be represent one of the example of the polynomial p of x, that is a1 x to the power of e to the power of 1 plus a2 x to the power of e to the power of 2 and so on an with n terms, right? An x to the power of e to the power of n. When we are representing the polynomial, we are going to be consider the order pair ai and ei, or otherwise we are going to be write it as ei or ai, what it may be. Here I am going to write that one. That is the exponent and coefficient order pair, right? That means because in our previous video also we are consider an array. The array, each location consisting the two parts. In one part we are going to be save the coefficient, in another part we save the exponent. So here we save the coefficient a, in this part we save the exponent e. So we also know that all the coefficients may be integers or floating points, but all the exponents should be the integers. So what are the functions I am going to be used to represent the polynomial ADT? So to perform the operation, I am going to be consider actually the poly means polynomial, that means that is the resultant polynomial. Poly 1, poly 1 means one of the example polynomial. Poly 2 means another example polynomials. Here COEF represents coefficients. All the coefficients belongs to the coefficients category. I am going to write here, and I write EXPON exponents. All the exponents belongs to the exponents set or exponents category. So this is the introduction about the polynomial ADT, and below that one I am going to be represent this one, the first function polynomial. That means polynomial, the written type is a polynomial. Because we are adding the two polynomial, we are going to be performing any operation on the two polynomials. For example, 3x square plus 2x plus 1, this is the polynomial ax, and one more polynomial bx equal to 4x square minus 5x plus 7. Suppose we are going to be adding to this one 7x square, that means ax plus bx 7x square minus 3x plus 8. So we are adding the poly 1 plus poly 2. We are getting the result only the polynomial. So the written type is also the polynomial. For that reason, I am going to be, after executing this function, the polynomial is returned. Okay. So for that reason, I write like that. Sorry, this is a little bit, it will be taken. So here I am going to be, here I am going to be 0. The first function is the 0. This function return the polynomial. Suppose there is no polynomial, that means p of x. Here I am going to consider polynomial p of x. There is no p of x, that means there is no existence of the polynomial. It return the 0. Boolean is 0. That means if there is no polynomial, it returns true here. That means p of x is 0, it returns true. Suppose there is a polynomial like 3x square plus 4x plus 1. This is the p of x polynomial. P of x equal to this one. It returns false because the polynomial existed. The polynomial is not the 0. So for that reason it returns false. Suppose there is no polynomial, it returns true. The next one is the coefficient. So coefficient, suppose I am going to be try to be coefficient. Suppose I would like to find out the coefficient 4 either belongs to polynomial p of x. I return the value of the coefficient and polynomial. Suppose the coefficient 4 existed in the polynomial, it returns the coefficient, else it returns the 0. Suppose there is no coefficient of 7, 7 not belongs to p of x. So this coefficient function is returns the 0. Here the coefficient function returns the 4. In the same way, exponent, lead exponent, suppose I am going to be given the polynomial for this function. Suppose uh, 5x to the power of 9 plus 6x square plus 7. So this is the polynomial p of x. I given to the this function. So lead expo, it returns the 9. That means the highest degree of the exponent is 9. So for that reason, it returns the 9. And attach the one more one is the, suppose attach poly quotient exponent. So I have the 5x to the power of 9 plus 6x square plus 7. This is the polynomial. I am going to given 4x to the power of x cube. So this is the coefficient, this is the exponent. I am using this attach function. This term is also be added to this one, and final polynomial is 5x to the power of 9 plus 4x cube plus 6x square plus 7. That means the new term is attached to the existing polynomial. Right? Remove. In the same way, I would like to remove any term. Suppose from this polynomial I would like to remove 6x square. I will give the coefficient value 6 and exponent value 7. Then actually, or exponent value x square term I would like to remove. Now I will give the this one, actually exponent value. This remove function removes from this one. Now the final polynomial is 5x to the power of 9 plus 4x cube plus 7, because the remove function will remove the, right. Okay, so this is, I am going to use single unit polynomial coefficient exponent. It returns the polynomials coefficients and exponents. Suppose I use this polynomial, that means I am going to consider this is the p of x. The p of x single unit of p of x, I'm going to write it. So the coefficients are 5, 4, 7, and exponents are 9, 3, 0 are returned by this function. Suppose, and the next one is addition of two polynomials and multiplication of the two polynomials. I am already explained the addition. Suppose 3x square plus 2x plus 1. This is the first polynomial, and 3 x cube plus 4x minus 7. This is the second polynomial. By adding these two polynomials, the resultant polynomial is 3x cube plus 3x square plus 6x minus 6. So we are adding these two polynomials. Suppose when we try to multiply these two polynomials, right, 3x square plus 2x plus 1 and 3x cube plus 4x minus 7. So by using the first term, we are multiplying the all the entire polynomial in second polynomial. That means 3x square into 3x cube plus 3x square into 4x minus 21 21 x square. So this one we are going to be add 3 into 3 9 x square, that equal to this term actually. And then by using the second term we are going to be perform the same. So plus 2x into 3x cube plus 8 x into x 8x square by this one and this one, and minus 14x by using the third term, right, plus 1 into 3x square 3x cube plus that is equal to 3x cube plus 4x minus 7. By simplifying this one we are getting the result. Actually, there is no space, so for that reason, and to cut short the video, I stop here. Suppose we are simplifying this one, 9 x to the power of 5 plus 12 x cube minus 21 x square and so on. We are also simplifying this one. We are getting the multiplications of the polynomials. This is the actually how we are going to be polynomial ADT with suitable example. I hope friends you are all are understanding this video. Thank you.